Like if I ask you, like, what version of iOS are you running? It's like, do you know? Like, do you care? There's something to that effect, right? Where they're sort of like they're like, oh, you just use ChatGPT 5 and like you're good, right?
It's going to be used to generate arbitrary worlds that can then be used as like simulation environments for robots.
The longer context in practice, a couple of times when I've seen it, it's actually resulted in like worse quality output.
Is there a world where these like LLMs or whatever we end up coming with in the future, where they understand the world in a very different way, in their own way, but become more intelligent than us?
All right. Welcome to episode 5 of The Forward Pass. This is our monthly show where AI entrepreneurs cut through the noise. And all 6 of us, we're all building products at the frontier. And today we'll share our real challenges, technical insights, and unfiltered takes on where the industry is actually headed. So if you're building with LLMs and you want to sharpen your craft, this is the show for you. And today we have a special guest, Anson Whitmer, who is actually my co-founder at Metla, where we make an AI therapist. This is his first time joining us. And if he does well, then maybe he can join us again. All right. So today we'll have a number of topics. So the big thing this past week was the GPT-5 launch. We'll be talking about that kind of from a product perspective, the pricing strategy, what it means for OpenAI's product. And then we'll also talk about what it kind of means more broadly for the industry. Like, are we running off a cliff here in terms of performance, or is that just a temporary thing? We're also going to be talking about AI tools for data analysis. We're going to be talking about using simulations in order to improve our products. We're going to be talking about cloud TPM limits and why that space is kind of all over the place. And then we'll talk about context windows and whether Claude Sonnet introducing a 1 million context window opens up new applications, or whether it's not a big deal at all. So yeah, we'll get started. First, we'll talk about GPT-5. So I think a lot of us were surprised that it felt like it wasn't really a state-of-the-art model, but it did end up being very cheap. So it almost seems like it was just a way for OpenAI to lower their costs. Like, that was my interpretation of the launch. So yeah, who wants to share a hot take on GPT-5 and what it means?
Well, I'll comment on the cost, which I thought was quite surprising. So early this morning, I kicked off a job that ran about 2,600 web research agents. We're trying to basically figure out which people we should hire from academia. And the whole thing cost $130. I was expecting it to cost about 10 times that. It was something like 5 cents per agent. Now, part of this is because there was some back-end issues. I mean, that's a lot of agents competing for resources. And some of the web searching wasn't really working. But also I think GPT-5 was lazy. We ran it, this is GPT-5 with low reasoning mode. They shouldn't make it lazy with tool calling, but it was often answering the question about the candidate, like evaluating them, without doing the reading that it was supposed to do. It would just kind of look at the metadata and be like, oh, well, they're, at this Princeton AI lab, they must be great. And then it would finish. I'm like, you're an agent, like, use the web. But it was shocking to me that I can run that many agents and have them finish that quickly and it be that cheap on a quote unquote frontier model. Again, we'll talk about the quality of GPT-5 and GPT-5 low, but the price was like shocking. I was expecting that to cost over $1,000 and it was $133.
Yeah, I think one of the little bit of a challenging bit of talking about GPT-5 is that there's actually a whole bunch of different models out. So like GPT-5 is like, there's the GPT-5, there's the GPT-5 Thinking, and GPT-5 Pro. And the GPT-5 to me seems like it is basically a model that is a router between GPT 4.20 and then, or it goes to Thinking, which is like 03.1, just like slight little tweak and improvement to either one of those, but depends which one you get. And it seems like if you are expecting the Thinking one and you get the 4.20 or like the fast one, it's a kind of a bad model. But I think from the point of price that you were talking about is I think for a lot of free people, they're now actually able to get some amount of thinking that they didn't have before through the GPT-5. So it might not actually be saving them a lot of money. They're introducing people who previously didn't have thinking to thinking without having to like select O3 or 4.0.
Yeah, I'll jump off of that. I think the spicy part of this release for me was the routing, and it's like, dynamic and it's real time, and they respond to all these different signals that maybe they didn't take into account before. Two-edged sword, though. I think two-edged sword. I think there's definitely going to be cases where, okay, maybe they look at your template and then it's like, okay, sorry, not template, but your input and say, okay, well, this looks easy. We can handle it, and use a cheaper model, and you'll get faster responses, and the quality will be the same. So I'm sure they've tested against their benchmarks. I'm sure if it's come out ahead, it's probably better in key factors like latency, etc. I think the two-edged part is for people building products and not trying to optimize benchmarks. This now is a new source of volatility. So it's like, yeah, great. Benchmarks are great. To be honest, I don't fully understand them. Like, is it a little bit better on this? Like, how does that translate to my, the performance on the task, right? So that was sort of my takeaway. And I am, like more of a boomer, I guess, on the like new models, right? It's like, I think this has come up before, right? It's like, GPT 3.5 was great, right? That October 2023 context window, it's like that was good enough for a lot of tasks, right? And your problems became evals and all the stuff around it. And the underlying model improvements are like kind of hard to harness. And that's sort of like what we've seen.
Just try harder, Michael. Just try harder. It almost seems like they're explicitly saying with this release that they're like a product and consumer business rather than like an enterprise business almost. Maybe not quite that extreme, but like it's moving that direction. Like by saying we're going to make the lives of developers like us building products harder in exchange for like making our core, user who's cheating on their high school homework or whatever just a little bit happier. And to save money and to basically like do margin roll up on that and say we're actually going to start making money on those people, or at least losing less money on the free people such that the paid people can actually be a net win. That felt like it was what it was to me. They're just saying we're a consumer company.
Yeah, I think there is like a philosophical thing too, right? Like if I ask you, like, what version of iOS are you running? It's like, do you know? Like, do you care? Right? Also, like, do you even know what iPhone number you're on? It's like somewhere in the teens, right? It's like, and there's something to that effect, right? Where there's sort of like, they're like, oh, you just use ChatGPT 5 and like you're good, right? Versus where it was before, which is like the specific model mattered a lot. So I think there's a bit of that maybe shift in marketing and positioning.
Yeah, I asked my wife, who's not an AI, why she was using 4.0 instead of O3, and she was like, "Well, I want to use the better one because it's 4.0. It's a higher number, right?" Yeah, so definitely a lot of complexity there for people before that was not good for a consumer product.
Worst naming scheme of all time. I don't think it'll be topped anytime soon either.
Yeah, there was this shocking number that was like fewer than 10% of people that pay for ChatGPT were using O3. Whereas for me, O3 was the only reason I ever used ChatGPT or any OpenAI model for anything. Like it was all O3. Now, presumably with GPT-5, nobody needs O3 anymore, but people are paying $20 a month and they were still using 4.0. I bet inside OpenAI, they were looking at that data and they're like, well, people clearly don't care about model quality at all. So we should just absolutely optimize on like speed and throughput and things. And that leaves, even if only 1 or 5 or 10% of their users do care about model quality, we now feel like that OpenAI is not building for us.
Yeah, I think moving on to like still within GPT-5, but like almost like a little bit of a separate topic, and feel free to jump in, Chris and Ray, with any takes here, obviously. But on that point, it's almost like there's like the heady like Twitter people who are like, are we going to discover new science with these things, that kind of stuff, or are we about to like have like a Dyson sphere? Like those are the people who I think are a little disappointed by this, because it almost seems like we're approaching an S curve on like the frontier capabilities. Do you guys agree with that, or is this just like a myopic view and we're going to look back in 5 years and say, nope, it was just one more point on like the smooth exponential and there was no S curve at all, we were just kidding ourselves?
Can I just ask, are you finding GPT-5 thinking or GPT-5 Pro to be better than O3 or O3 Pro? Just vibes or eval?
I've mostly used GPT-5 inside of Cursor through like the high setting, and I think I I analyze it inside of Cursor more of like if I was an app builder using the API and I had access to it for like I think maybe several weeks to a month or however long they had access to. What I found extremely impressive is the continuous tool calling and thinking, reasoning, and then what Cursor was doing with the code to extract snippets and then ask further questions and then continue on forward with that. And to me, I love the experience because it felt more like a co-pilot, because I actually wanted to examine my code and actually refactor it myself. And so watching it going through the thinking traces was extremely helpful for me for an unfamiliar code base, because then I was able to see like, oh, it actually in its thinking trace said whatever I wanted to instruct it was a bad idea, but then it followed through with my actual request, and then I just stopped and it said, hey, hold on, let's explore the bad ideas. So I started prompting it differently going forward. It's like, in your output, please also give me the bad ideas too. And so that kind of helped me in this back and forth phase. And so I've been spending more time there, and I'm just really curious to see. I think there's a lot of interesting things that we haven't really played around, and I think we just have this extremely configurable thing that we're still trying to figure out. And I really can't wrap my head around everything yet. In terms of what I've been used to in Claude Code, giving it a bunch of tasks and doing research and coming back, it doesn't feel like it's going to replace anything anytime soon, or like having this great model architecture discussion. But for from a co-pilot perspective, taking a look at code with me and trying to pick apart files and go that back and forth, I actually found it kind of nice. Haven't really used it too much inside of ChatGPT, and I'm wondering, is there a difference between what the API is doing at all these different levels, and then what the app is doing as well in its instruction set? I mean, I would assume so, but I think there's also those overlapping discussions online too, in what people are talking about. I think some people are talking about the Chat GPT experience in chat versus like the API and then app builders that are building on top of that. Because I feel like we're still trying to figure out what this is.
Yeah. Yeah, Chris, I know you said in the group chat that you'd been using GPT-5 for coding this past few days. How did that go?
Yeah, it's been good. I mean, I've been using GPT-5 on Cursor and like comparing it to Claude Code. And with both, I'll say like the point about all this like dynamic switching and things and models going on. I find it when you're doing something with the models that like is your core job, like you're getting paid for coding or whatever it is you're doing. I just find it annoying when it like switches to a lesser model and you're kind of like prompting over and over again. And then so I for both of those I found just kind of like frustrating. But they have their like override settings where you can simply just like get an API key, say I want to pay for usage, and it's going to be more expensive, but I think you can sometimes rationalize it if you're getting paid for whatever it is you're working on and that sort of thing. So anyway, I've mostly switched over to like being very specific of like, I want to use this best, thinking model or whatever it is. And I do think they're with GPT-5 and I'd say like Claude, Opus, 4.0, 4.1 I felt like was not a huge change, maybe as good or maybe even slightly worse on some things than 4.0, but a different topic. But anyway, I think like those have been both really good. I think noticeable improvement when I compare my kind of like gut benchmark, I guess, on coding is like how many prompts does it take me to get to something I'm like checking in committing to the code base and stuff. And so I do think that those latest round of models have like improved that it is like does seem like fewer prompts to get there.
Yeah, I think that's actually a good intro into the next topic on the docket, which is Ray, you'd mentioned around Sonnet now has a 1 million context window. I think they just announced that yesterday, right? Or 2 days ago. That feels like a big update. I think they was it 128K before? So that's like an 8X. But yeah, Ray, do you want to tee us off on that one? And maybe have you found any use case for that? Or is it kind of just hype? Like, does it actually improve the ability to do more complex coding tasks? I don't really feel like in Cursor I have a good sense of how much of my context is actually being used at any given time, because that's kind of like their whole product is like context engineering of how to manage that. But I'm sure that behind the scenes they have like a config that refers to how much context the model can take. And if it's a larger number, I'm sure that they're able to put more in there, even without necessarily me changing anything about what I did when I queried it, especially for something significant like a refactor. But 128 is already a lot. I mean, that's already a significant amount of lines of code. But anyways, yeah, Ray, do you want to kick us off on that one?
Yeah, they just yesterday announced that Claude Sonnet 4 via the API, if you're tier 4 or above, or I guess you're tier 4 access for the model, that you'll be able to, over the API, query them and send over 1 million tokens for the context window. And I don't exactly know if the context window means that stuff that you're going to be feeding in and then allowing it space for the output as well. And so there's something like that as well. And then there's also a charge that's a premium cost, where if you have over 200,000 tokens in the context window, then the price, I don't quote me on the prices right now. Somebody can pull that up. I think that's kind of where it's at. But I think the question I was thinking about was about a paper from ChromaDB that they released on context rot. And if you have too many distractors in the context, then you can actually kind of throw the model off a little bit. And a lot of times, especially for people who just like vibe code, or I'm guilty of vibe coding. I feel like that's just been a big, season that I went into to try to generate software, is that you'll generate lots of repetitive code and patterns in all over your code base. And if you don't actually are diligent to remove them or just refactor them, then the larger the context window, I feel like you can put in a lot of those distractors. And when you're querying the model, your outputs may not be as good. And they're showing that like if you have like 4 distractors, even though you have a nice big context window, your level of quality can dip like almost like 50 to 60% or more.
Yeah.
And it's kind of it's shocking, but it's actually something that people have have seen, that like say, I just wanted you to move the button 3 inches or something, and it does something else in your code base. It's just like kind of like that type of thing. So I'm just curious. I don't have any formal benchmarks, and I haven't really had a chance to try it fully yet, because I'm a little leery of that. But I'm is this gonna, for me, I just have more questions than anything. I was like, we previously talked about Google's large context window, and I don't hear people going crazy over that. And and has anyone actually used it as a RAG pipeline type of thing, where you just shove a bunch of things in? Is it maybe not code related, but other things are really good at it? I'm just kind of curious to see what domains this will do well in.
Yeah, we've never needed that nearly that much for our AI therapist, even though our context can be very significantly long. We've never needed nearly 1 million. I think you do get a quality issue when you have that many. I heard Dario from Anthropic recently say that someone was talking about continual learning, meaning is it able to learn on the job? And he almost was just like, well, if we have 1 trillion tokens in the context, then that's like the amount of tokens a human takes in their lifetime. And so then that solves it. And I was like, really? Like, that's such a weird answer. Like, I don't know.
Actually, Jeff Dean said the same thing. When he was talking to Dwarkesh, he basically said, we need trillion token context windows so we can put the entire Google code base into a single prompt and then help Google engineers write better code. or just
Yeah.
automate the writing of really high quality code. I had the same reaction as you, Tyler. I thought that's insane. Like putting an entire lifetime's worth of learning into one input as a way of solving the problem, that can't possibly be the actual solution.
Yeah, even with the amount of context we have, which is in our like prompts with our AI therapist, which is less than 1 million, you definitely see ordering effects. Like if someone gets moved forward or not, it really changes the quality of the output. What's emphasized by the auto regression, which it makes sense. Later tokens matter more, and so you're gonna have an impact there. But even to the point of like 1 trillion, and this is continual learning. It like even say outside engineering, where I'm gonna try to understand a human and say 1 trillion tokens their whole life. But say you think about your spouse, your partner, you don't remember exactly what they said yesterday at 11:12 a.m. And what they have said every single second that you've been with them over the past years. What you do is you learn about them. And learning is where you build continually more abstract and higher level representations about a person. So you start to understand, oh, they prefer this. If I talk to them in this tone, they won't be happy. Like you have this like general higher level understanding of who this person is. That's what matters, not what they said yesterday at 11:15 a.m. And so it's the same thing with like the trillion tokens. We think 1 trillion tokens is going to help you understand a person. No, it's not. Maybe with reason, you could process and chunk the 1 trillion tokens and arrive at some like higher level, more generalized representations of what all this information means. And then it becomes useful. But if you have 1 trillion token or 1 million context window, like you have to do that thinking, that generalization to then make it useful. So I think it puts a lot more demand on the reasoning models to do this stuff on the fly. And really where we need to go in the future is not 1 trillion token context window, but we need ways to be able to represent people at gradually more abstract, higher levels.
Yeah, and not just people, but almost any abstract concept as well.
Yeah, I can. Let me jump in here. I think you can kind of see how we got here with like this trillion tokens, right? It's like trillion, why not like 2 trillion, right? Maybe that's the threshold. I don't know. But I think it's also just like these are the tools we have. It's easier to just make one of the numbers higher and say like now it works. Like learning abstract concepts is not something we've made that much progress with in terms of research, but there's like increasing tokens, increasing layers, like maybe that that is an easier problem to solve, or it's more tractable given what we know now versus like, oh, we need a new breakthrough to like create a better higher order representation.
I totally agree, Michael, but it's surprising to hear like the best engineers in the world, like Dario Amodei and Jeff Dean, like say that. I'm not going to include Sam Altman in the best engineers in the world, but he did say the same thing. It's surprising to hear those caliber of people say that when you would think that they would have been able to see through that type of faulty reasoning. I don't know.
Well, I mean, I think I'll take maybe the cop out cynical route, which is that, you know, they kind of have to talk their own book, right?
Yeah, fair enough.
If they're like, oh, we don't really know the direction, they'll just throw out like a goal that's really far away, right?
Curious from. Oh yeah, go ahead.
Sorry, just
I was
one
just
last
curious
thing, really quick.
Yeah, go ahead. Mm-hmm.
So on the topic of Gemini, I think it was we did run one experiment. So just for context, we have a pipeline. Includes RAG, and we have the same thing where for many models, if you put in too much stuff, there's a recency bias, or like it basically forgets the stuff in the middle. So if you're like, oh, RAG is complicated, let's just dump everything in there, then it's going to ignore a lot of what you send. However, our test with Gemini actually revealed that they somehow have that problem is way less pronounced in Gemini. So even with the full context, it seems to not forget stuff that's in the middle. So that was a big surprise for us, and we did some more tests. Currently, or where we left it was the issue where if you are over what they consider the large context threshold, you get into a different pool of load balancing, and so your requests take very long to run and usually time out, right? Or it takes longer to run than our what we want to spend on our completion. So yeah, for what it's worth, that was our finding. So we obviously, I think the Claude one just came out, so we'll have to experiment there. But It is nice in the sense that like you replace the RAG problem with throw it at the LLM and hope that they can like return the results to you in time.
Yeah, I was curious. Does this math assume that the models will also get like 100x bigger from a parameter standpoint? And like I don't know, like I'm not a ML specific person here, but like I was thinking about, is there a relationship to the context window and like the parameters and how they're activated, right? Like if you're assuming that you can go 1 trillion parameters, does that also mean that the more general the knowledge is and the bigger the parameters and the more data it has about the world, that it can actually draw better relationships or something here? I don't know if there is an equation that balances the two, and our assumptions of what we think about prompting models today will change when it's actually at this 1 trillion token context window. I don't know, just have a lot of questions. Yeah.
Yeah, well, I think there's a couple questions there. One is a sort of around the idea of like, is a smarter model able to handle a larger context better than a dumber model? And I think there is some sort of transfer learning there that it is able to do that. I believe I remember a paper from a while back where they gave a long context to basically a pretty dumb model, and it basically wasn't able to use it effectively, which kind of makes sense. It's almost like you give a smart person a lot of information, it can kind of reason through that. But then from like a computational perspective, correct me if I'm wrong on this, but my understanding is like the computation, like the number of flops to actually, return the result, will be linear with the number of parameters in the model. If there's a mixture of experts, that gets a little more complex because it depends on how many experts are activated on that model. But roughly, the number of active parameters is linear to the computation. And then in the naive original attention algorithm, it's actually quadratic on the context window. But there's actually a number of techniques. There's one called like flash attention that makes it subquadratic, but it's still it's not linear. It's not linear with the context window. So if you 10x the context window, I don't know the exact like state of the art of big O notation for where it's at, but I think it's somewhere between like n log n and like n squared right now. So it's significant. It's not just a linear, and that's part of the reason that I think these systems are charging a lot more per token for the longer context, and why they're probably timing out.
Yeah, I do. I'm still, as regular listeners of this show will know, I'm still under the view that intelligence will improve like fairly rapidly. Like we're not leveling off, and GPT-5 is a meaningful point in those kind of like number of hours of human work that can be replicated in those various graphs that people see. But there is something too of from the provider's perspective, it's uncertain whether they will produce more intelligence breakthroughs, but they can definitely optimize the ones that they have. And so that makes it a good sales point. Like you can handle more context. Like everybody can understand that. You don't have to, again, you don't have to understand if O3 or 4.0 is a better model. You just take a given model. It's like, oh, this can just handle more. And again, they're getting paid by the token. I mean, outside of ChatGPT over the APIs, they're getting paid by the token. So they want people to be dumping books of information in there, even if it's not clear that they actually need to do that. So I think to some degree, it's kind of like it's a conservative play. But my view is ultimately this won't matter. When we look back on this, no one will care like how many tokens Claude 4 can handle. All that's going to matter is what Claude 6 is capable of.
Cool. Chris, any takes on the long context window?
I'd say like in practice, when I've used it, there has been like times where it's been kind of interesting, like what's the quality of output if you give it, say, like a whole repo of a large code base and ask it to like examine everything and write summaries, or like one interesting thing was like come up with a style guide and like guidelines for this that you'll then follow later, and that, so there's been things like that, and then another kind of example I've had was like an AI chat that was based on like trying to create a specific like personality that was had its own kind of like world and all these characters and their backstories and everything with the world. So it was, having like a ton of context in that. but in that example, I felt like the longer context caused it to like almost lose small details in the system prompt, where we would say like never do this, or something like that, and it would, with that longer context, it would occasionally forget those rules and those things. And so I felt like the longer context in practice, a couple of times when I've seen it, it's actually resulted in like worse quality output, or like not listening to some small details. But yeah, I don't have a lot of scientific like tests that was rigorous on that. It was more just kind of in use. Yeah.
Yeah, we've seen it with evals and our AI therapists in terms of like we're well within our context limits, but we do quite a bit of processing on the fly to simplify information or find ways to reduce how much context we're giving, so it has a big impact on what the quality is. And earlier I was talking about more abstract representations, and you could do RAG and we could retrieve what you said in previous conversation that is relevant to what you're saying right now, and it's just this back and forth conversation. But what's really actually helpful is to know how that is related to the current conversation. And there's a processing step there, right? And if you have that processing step about, they said something and it's kind of a little bit more abstract, high level representation of what they previously said and how it's relevant to now, that is super impactful on the quality of what your model is. Dump it in context, that's just random. And then you hope the model's going to figure out how that applies. And now is to, I think, Ray's earlier point about there's just a lot of distraction in there. You lose model quality.
Yeah. I think we get back to a topic we talked about last month, which is context engineering, which is like the new version of prompt engineering. I think that's actually a good example of that. Daniel, you were kind of asking, what does that term even mean? To me, that's a good example of it, where it's like you're not just like stuffing a bunch of extra shit into the prompt. You're actually like doing some sort of smarter thing where you're like connecting ideas, or like running a small model to summarize something, or having like a sub process, and then putting like very high quality things into the context so that the context is like engineered to like get you the results you want. And I actually don't think that for most context engineering type of problems, like a longer context window is a solution. It's actually probably moving in the wrong direction for most people. Most people probably would do better to actually like synthesize more and have more like intermediate analysis, whether that includes like a RAG step in there somewhere or not. And then only really put high quality information into the prompt, which is actually kind of similar to like the way that you hear the people who do the pre-training process. They talk more about like quality of data actually matters more now than quantity of data. And I think that there's a similar thing within like inference. So, okay, cool. Yeah, go ahead, Chris.
I was just gonna say too, yeah, I wonder if it's kind of related to another topic we have of like data analysis and stuff. But the long context, like you can imagine, you give it like I don't know, API logs, or build output logs, and or just like results from queries, data queries and things, and it's like finding like patterns or different specific things within that. I could see it being useful for that, as opposed to like just a giant like prompt kind of input and remembering everything. So yeah, that's one area I'm kind of like curious to try it on and see how well it does.
Yeah, that's a good point. Raw logs where there's like an error code somewhere in the middle. That's kind of the needle in the haystack. And I think that is actually the one use case where long context is really helpful, is like finding the one thing out of the million. It is really good for that. But that's almost like, to me, that's almost the only problem that I've seen long context be like reliably better than alternatives for. Okay, cool. So actually that really gets us into your next topic, Chris, which was around data analysis. I think, I don't know if you're just, like writing SQL yourself, or you just want a bot that does it for you. But yeah, do you want to tee that one up for us?
Yeah. So I guess I was curious to hear, this group's experience, if there is any, with like essentially hooking up a data warehouse to, say like an AI like chat interface to ask questions about your data, in kind of like a natural language interface and get back, say summaries or insights or, so it's almost like instead of, Cursor hooking up to a code base and kind of working with it, it's like, imagine if, Cursor was hooked up to your data warehouse and you're able to like, get charting out of it and everything else as well. So I know there are some products kind of like in this space already. But yeah, I was kind of curious if you all have tried anything in that space or some of your experience with it.
Yeah, I have a long philosophical answer to that, but maybe I don't know if you guys have specific examples. Maybe that's a better place to start.
Just give us your full answer, Michael.
All right. How much time we got? Okay, so I think the topic of BI comes up a lot, of data, and like I think there was a lot, like maybe the last 10, 15 years, there's this like, let's be data centric, let's look at the data, right? Don't just make decisions based on gut feel. I think that is sort of like, that was the pitch of like, the inherent thing is like, okay, there's truth somewhere in this data to be found. But really, like a lot of the real problems are like, oh, you have to convince people to do this, or like the signals are very messy, right? It's like you're like, okay, this is what's happening with engagement, and the intervention is this, and then this is the new engagement, right? And it's all up and to the right. In practice, though, right, like real life data is like, the real questions are like, which metric should we measure, right? That's the hard one. And then you're like, well, I don't know, let's like find 5 and like pick the best ones, right? And then the metrics will like they will like not necessarily correlate, or they'll be too correlated. You'll kind of end up with this mess of like lines, and it won't really, it'll kind of look stochastic, right? So that's kind of the starting place, right? Of like, okay, so you have this data warehouse, and then you're trying to get to this like a clean PowerPoint slide, right? That you can like get your execs on board with, or whatever. You can like organize people for the next initiative, right? And there's a lot of stuff that gets lost in between. There's like a lot of tooling. There's tons of tooling, tons of companies out here doing this, but whether or not they solve the real problem is like, I think, kind of dubious. And I say this, and I really like the tools, right? I think this is like, in fact, I would say I'm passionate about it, but it just like the ultimate goal that you're trying to solve is very hard to answer with the data warehouse. There's also just like the inherent cost. You need to pay for your Snowflake bills. You need to pay for an analyst to like keep them up to date, and then you need to like, you're like, okay, and then they maybe switch jobs or switch teams, and then you're like, oh no, the sales one versus the marketing one, these are like slightly different ways to measure users. So it kind of just starts getting messy real fast. Anthony, looks like you want to jump in there.
No, yeah, I mean you're totally right. It's so much more than just presenting data. There's all like the skills around it, which is like persuading people, and that's going to be storytelling with the data, making the case is something that's there. And what I've seen, I haven't looked to see what's out like quite recently, but what I've seen before is there's different types of like data analysis you could do, and there's like descriptive statistics where you're like, hey, this number is higher than this number, et cetera, and you're querying the database and you're showing those types of numbers. I think AI is going to be quite good at that kind of stuff. I mean, it's like co-occurrence is what LLMs do, pattern matching, et cetera. But what the other type of, like if you're a data scientist, and this is where I got to know Chris and Tyler, was head of data at Calm, is where you are trying to understand causality. You're trying to explain things. You're trying to predict, if we change this lever, what is going to happen? That's different from just like giving you stats. You have to understand underlying mechanisms. And because LLMs are kind of understanding statistical co-occurrence and less grounded in causality, I've generally found that they struggle to be able to explain causal mechanisms as well. And so I think from this perspective of like, if we change this lever, what's going to happen? And so then you go out and do it and run A/B tests and prove that it does happen. My guess is that this is going to be a much harder challenge for AI. So it's kind of like what you want. If you want to be able to get a quicker understanding of what's going on in your data and describe it, I think we're there and we've been there. But to have it give you those causal mechanisms and then turn that into a story so you could persuade executives or the CEO or the company to act in a different way. Yeah, those are all harder challenges, and we're probably not there.
Yeah, that makes sense. I guess it's kind of like analogy of you know, being able to say give a model your code base and then asking it like, what should we implement next? It's like it'll tell you some ideas, but it's probably not going to be the right things to do. Yeah.
Just got to wait till the CEO is an AI as well. So, cool. Any more takes on the data science tooling? I'm actually surprised. I'll go quick here. I'm surprised like Databricks or Snowflake. Actually, I don't know about Snowflake. I shouldn't speak on that. But Databricks, like it's still really primitive. Like even when I'm like just writing SQL in their browser experience, like it doesn't even autocomplete for me. And I'm like, what is this? You don't even have like the equivalent of like 2022 tech here. Can't believe that. You know my entire schema. It's sitting there right on the left. Like you can just put it in text form into the like. How do you not have this? Where I can just say like, how many users came in yesterday, and it just like I'm shocked that they don't have that yet. It's honestly like malpractice. They have all kinds of like crazy like hosting of like training runs and like cloud distribute. But I'm just trying to write SQL in your product, and it's like I'm going to cursor, pasting in. So, anyways, I'll stop my rant. I'll stop.
Sounds like you have a $1 billion SaaS idea there.
Well, I'd need to own Databricks. It has to be integrated. That's like the whole point. There's already other solutions if I copy paste out. It's just that I'm surprised Databricks hasn't done it themselves. But I guess it's just innovator's dilemma. Like,
A big difference here is contextualizing things based on data that you don't have, because LLMs have memorized a lot about the world, but they can also search the web. So let's say you've got your retention number is around 15% month over month, and then you do some innovation and it bumps it up to 16% in your test, or so you think, and you're trying to establish some sort of relationship there. Well, what is the retention of your competitors? Like, is that good? I mean, that's something you can Google it, I guess. You can try to read it. People have some of these numbers kind of off the top of their head, but those numbers can be wrong. But if you do some research on your competitors and it's actually good, then you can get a sense of what retention numbers you actually need to have. Or maybe it's improving for them, or maybe it's getting worse for them for some sort of tailwind that you're all experiencing, or headwind or something like that. So if your data analysis involves data you don't have, if it involves data on the web or from your competitors, AI can actually be a huge game changer, because you previously would just not have any of that, or you'd have like a very superficial, like the first Google results gave me this like spammy article that said everybody's retention is 30%, and I'm just going on that, as opposed to like good data on your competitors, your users, the trends, things like that.
That reminds me of a product that somebody has where they scan every single podcast transcript, and you can subscribe to keywords. So if your product is mentioned in their things, they'll send you an email or send you a whole thing. So you can also do that, right, with this type of thing. If your competitors are actually on podcasts and leak alpha by accident, or their employees, you technically will have this data collected, and you can reason over it, right, at some point in time in the future. That's interesting.
yeah, that's awesome. That's a really cool thing. I was thinking about building that like 2 years ago when I first saw that the Whisper model was so good at transcribing, but I was already building another startup, so I never did it. So I'm glad someone did that with the podcast transcribe and make them searchable and indexable. Does anyone have I know Dan, it's a consistent complaint of yours that Google keeps announcing things, OpenAI as well sometimes, but Google keeps announcing things and not having them available. They did that again with this Genie 2 model, which I'm sure we've all seen. I actually think it was the most impressive AI demo that I've seen this year. I thought it was just completely mind-blowing. To me, it felt like 3 years ahead of where I thought these systems were at. So I'm sure a lot of the listeners have seen it already, but if you haven't, it's basically full-on world simulation. And so what you can do is you can just say, like, make me riding on the back of a polar bear in like wearing a medieval knight costume or whatever, and I have a sword or something, and then you're doing it, and then it's fully controllable. It's like a video game, and it remembers like it's like a modifiable world. There was this other demo they did where like somebody was just like painting a wall, and they like painted like a very specific pattern on the wall, and then they looked away, walked to like another room, came back, and like the wall still had the exact same paint on it, which was just incredible for anyone who knows kind of how these underlying systems work. That's really impressive. And then they also already, apparently, according to the demo, have the ability to like add an additional prompt, which is like a separate pipeline, I guess. But you can then say like, oh, make like a wolf come and attack us right now, and then like the wolf will just like come in. And so like I was blown away by this. A lot of people were talking about the fact that this is going to be used to like train, that like the end game here is not like video games, which is what seems like the initial use case, but is actually more like it's going to be used to generate arbitrary worlds that can then be used as like simulation environments for robots in order to try to solve like the hard problems in robotics. So yeah, any takes on this? Have you guys like heard anything more than just like the YouTube video that they put out, or is that all we really have?
Comment on the robot thing, because I agree that is the most fundamental question here. And I'm no expert on this, but there's been some speculation about how training data maybe actually isn't the thing that is preventing us from going into our glorious robot future. Because I had the same reaction. Like, okay, the reason self-driving cars took so long is because we had to drive millions of miles with, LiDARs, radars, cameras, taking everything. But arguably, a lot of that data is there, and humans learn with a lot less data than that. It's more the reinforcement part of the reinforcement learning, which is you take some action and it has some effect on the world, and you can learn the consequences of that and learn to predict that. Can this do that? Like maybe, like you say, I'm on my polar bear, and I say like, okay, I swing my sword at the wolf. Does it have high enough fidelity that you can learn whether that action is actually good and be rewarded? If so, that interactivity might mean it's a completely different type of training data that might actually be the single thing that unlocks training of robots. But I'm skeptical because these generative things aren't very good. And like swinging the sword at the wolf may not actually give you the actual consequences of what you would have done if you were a robot in the real world taking that action. So
Yeah.
that's what I would pay attention to. Like, is the interactivity good enough that you can do it a million times and learn what actions actually lead to the goals you care about? Because if so, I expect to see robots coming pretty soon.
I agree with that, because also, I mean, if I'm just thinking about like all of the existing video games that do have good physics, I mean, are we really saying that like spending an arbitrary amount of time in like a Minecraft world or, like a Elder Scrolls, like why is that not sufficient? Like I can go anywhere and I can swing my sword and it'll always respond well. Like how is that not enough data? Because I can just keep replaying that in different scenarios. And clearly like those underlying game engines, which are like actually like physics based and kind of ironically enough also run on GPUs, like maybe there's some deep connection there. I don't know. But, God is doing matrix multiplication or something. But like, I don't really understand why is my PlayStation 5 like not sufficient to generate training data for a robot to learn? I don't really get that.
Well,
I
it is
think
different to train a player of that video game, right? Let's all remember where OpenAI got started. Like in 2015, they were training things to play Dota, and they got really, really, really good at that. I mean, Michael, you probably understand better than I do how good they actually got at Dota. But it got like, human world champion level of Dota, but just in Dota. And there was no transfer. Just like AlphaZero was like great at the like deterministic full information turn-based games, but could do absolutely nothing on any other problem. That thing never got any good, didn't get good at anything else. But a fully generative world simulation thing can simulate more than just the Unreal Engine or whatever's going on in Morrowind. And potentially, if you're trying to teach a robot hand to hold an object, you could simulate it in so many different ways that even though it's maybe the same physics engine, or maybe not, I have no idea what the relation is between physics engines and this new Genie thing, but it could give you the amount of variation that would let you handle it in real world context, which is where the best video game ever made is actually just very specific to that video game, and that's all you ever learn how to do.
Wasn't it someone in this group, maybe Tyler? I think it was like Sora, or maybe this was a couple of years ago. The rumor was that it was the training data was derived from the Unreal Engine, or they just ran like a bunch of different combinations, and then they like the training data was Unreal, and then the LLMs learned how to behave like Unreal, right, to simulate Unreal Engine.
Yes, I did. I think NVIDIA had like a patch where they could do like camera manipulation, or it was basically like NVIDIA using their GPUs for their original intention, which was video games, and then kind of training that to generate video.
I love the point, Dan, though, about how the fidelity matters if you're going to use it for training. And this generalizes outside of this situation as well. As I think a lot of people are using simulation in their work. like we simulate clients with our AI therapists and see how run evals to see how our changes in our models are working, and you get weird things. Like sometimes it can work well, but for example, if you were to ask a AI client, if the therapist asks him, like, does this remind you of something specific when you're a kid, or like there's some retrieval involved? A human will often be like, oh, I don't know. Or like sometimes they'll remember, sometimes they won't. But AI remembers it 100% of the time. And they always retrieve something that's really helpful for the therapist. Or maybe you told them to be kind of a little more combative and they go like, I'm not answering that. But it's one of the two. And it's not very human-like in its variability. And so if the model could end up learning, hey, I should always ask this specific type of question for them to retrieve something. And that's actually really hard for humans and would be a really bad thing to do. But so like the simulations can have like really subtle, weird impacts on training that are hard to see, even if overall they're helpful.
Maybe this is more of a throwaway comment, but humans do have this problem as well. Like there was a critique of the entire school of psychotherapy that therapists were effectively teaching people to hallucinate false memories of childhood abuse. So it's not just AIs where if you ask them, did you have any childhood trauma, they will just make up and always answer yes. Humans, under the right prompting, will also just answer yes to that question when they in fact had no childhood trauma.
Yeah, I think the LLMs teach us what it means to be human by being more like us than we want them to be in some ways. But yeah, I think that general point about simulations being subtly wrong and leading the system down a bad path is a very deep problem, and maybe it's even like the last problem in AI. It feels to me like we are now in a regime where when you have quality data, for whatever version of the word quality you want to define, when you have quality data, you can solve a problem if you have enough of it. I agree that they're not nearly as efficient as human brains. But I think then you get into the question of like, is the better analogy for our brains like the billion years of mammalian evolution that led us to have a head and all of that? Like, is that the right analogy, or is it like the 12 hours that I had to sit behind the driver's steering wheel and actually learn how to drive? I don't know about the sample efficiency. I think you can kind of take both views on that, but like the real issue is data quality. And I think if you can get a world simulator that gives you quality data, even for like the long tail of things, because for example, if I'm going to like get a humanoid robot into my house, my 5-year-old is very excited to get a humanoid robot. Every time I bring it up, she's like amazed, and I told her recently maybe we could get one, and then she's like, but Dad, like if it does all the laundry, like won't it feel so upset? Like I think we should still do some of the chores so it doesn't just think that we're just like lazy or whatever. Anyways, I think if I'm going to let a humanoid robot into my house, like I can't just be like, yeah, 99.9% of the time it's not going to like fall and crush my toddler, like no, like it needs to never do that, so there is kind of that safety aspect of, bringing a 200-pound piece of metal into your house. Like you really need that long tail of data in a similar way to self-driving, right? Like maybe the kid with the bouncing ball running out into the street is only 1 out of every 100 million miles, but like you better get that right when it happens, so
Aside from that, just throwing this out, just like I call this bro science theory more than it is like engineering theory, but it's always kind of an interesting problem to think about. And it's like, is there a world where these like LLMs or whatever we end up coming with in the future, where they understand the world in a very different way, in their own way, but become more intelligent than us? And then they seem to understand and learn faster than we can even comprehend or train them. Like they start to build their own tooling, they start to train themselves, right? If they get to a point where they're so PhD level where they say, oh, I can make my tools and do their own autonomous things.
yeah.
Is that something that will change our way of thinking and interacting with them? It's like, I don't know. I'm just kind of curious. I'm just throwing that out there for you guys to comment on.
It's almost like the AIs are creating their own simulations at that point, and that's when like the snake bites its own tail at some level.
But that has to happen for it to get superhuman, right? I mean, no matter how fast progress is, if all the training data is human data, it will just be human. It might be somewhat better in some cases because it'll have a better memory. but it will be fundamentally it'll max out at the level that a human can do. But once you start doing the simulations, then there's basically no limit, or there may be like philosophical or like physics theoretical limits on intelligence, but it won't be human limited anymore. So in that sense, the simulations are absolutely key. I mean, people have been talking about synthetic data for years. It's not like this is a new idea, but maybe the more examples that we see of this actually working in practice. Although again, even for training of GPT-5, I don't think we have any idea how much of that was synthetic data versus just very carefully curated normal data. But to the extent that we learn that AI can help with the preparation of data for the next generation of AI, that removes the human upper bound, I think, on systems.
Right.
Yeah, completely agreed. I think that's kind of that's been the goal, right? Is like the synthetic data is a requirement for this thing to go faster than we can.
Yeah, like AlphaGo, I think, was the first big example of that, playing against itself, right? Very simple world, but still a complex world that it was able to fully simulate and interact with itself. I think so. We have one more topic. It almost feels funny to go from like the most philosophical down to like cloud TPM limits, but or we could just call it there and just end on the "Are we all living in a simulation?" type of thing. Or Dan, do you want to close us out with the TPM limits?
Let's save that for next time. I'm just complaining that I can't get the TPMs to launch my products. Like, why don't the cloud providers let me pay more? But no, I was
Right.
quite seriousness. Like, you see better simulations coming out of DeepMind. I think it does marginally increase the probability that we are living in a simulation right now.
I agree. I actually agree with that.
The book recommendation, if you haven't read it, Permutation City, takes this concept very deeply. Yeah.
I mean, saying synthetic data sounds kind of cool, but saying world simulation sounds way cooler, even though it's actually the same thing. But all right, guys, another great episode. See you all next month. Bye.
Good stuff. See ya.